So we're going to start the amines this week and see how we get on with that. So the amines are basically derivatives of ammonia, and if you kind of look at this molecule, hang on a second. Have a look at this molecule here. This is ammonia, and every time you substitute a hydrogen with an alkyl group, we now have an amine. And just like alcohols, amines can be classified as primary, secondary, or tertiary. So if an amine has one alkyl group attached to the carbon, then we have a primary amine. If we have a look at this one, this has got two alkyl groups. They could be the same or they could be different. Then this would make it a secondary amine. And then if we've got three alkyl groups attached, as we've got in this one here, this would be a tertiary amine. Now, the thing about ammonia and the amines is that they have a lone pair here, which means that they can form a dative covalent bond to another R group. And we'll look at how that happens a little bit later on. So in this one here, we've got 1, 2, 3, 4 alkyl groups. So this is a quaternary, but it's not an amine anymore because it's got a positive charge here. We call it the quaternary alkyl ammonium ion, okay? And we should have alkyl there, quaternary alkyl ammonium ion. When we're naming these, there's a couple of ways that we can name them. We can name them using like amine. So for example, methylamine, ethylamine, phenylamine. Now phenyl, you need to kind of remember this, is another name for benzene. And we always use phenyl instead of benzene when we're with the amines. Just like the OH in alcohols becomes a hydroxy when there's another functional group with a higher priority. Benzene is lower in priority than the amine, so its name changes to phenylamine or phenyl. When we've got multiple substitution in these, such as these three down here, we use the N as we've used when we did this in the derivatives of the carboxylic acid. So on the nitrogen here, I've got a methyl group coming off it, so that's N-methyl. And then I've got 3 carbons in the chain there, so that will be propylamine. In this one, I've got 2 methyl groups. That's going to be dimethyl, both of them on the N. So if you think about when we do them with the numbers, we do something like 2,2-dimethyl. Well, because they're on the N, we need the N twice, so N-N dimethyl butylamine. With this one, I'm going to name this one. Ignore that, that's not correct. We've got an ethyl and we've got a methyl on here. And then along this part here, I've got 4 carbons. So the long chain is going to be the butylamine. So we'll start with that, butylamine. I've then got an N-ethyl here and an N-methyl here, and we put them on alphabetically, which means the ethyl will go before the methyl. So N dash, we treat the N like a number, so we need a dash, N ethyl, N methyl butylamine. Okay. So have a go at the naming and the drawing of the structures on here. Pause the video now while you do it, and then come back to it. We'll press play once you've done it and you can check your answers off, because I'm going to do that now. So this first one here then, we've got 1, 2, 3, 4, 5, which means that's going to be pentylamine. There is an alternative name for this, and sometimes it's easier to think of it in a different way. You could call this 1-amino pentane, okay? And as I say, you look at the structure and just sometimes you get this with experience. Sometimes it's easier to name it that way, and other times it's easier to name it in a slightly different way. With this one, so I've got my amine group about there. My longest chain of carbons is here, and I've got 3 of them there. So that is going to be propylamine. So propylamine. And then on the N, I have an ethyl group here. So that's going to be N ethyl propylamine. With this one, so I've got my N here, my longest chain of carbons is this one here, 1, 2, 3, 4. So it's going to be butylamine, and then I've got a methyl and an ethyl. So the ethyl is going to be named first. So N ethyl, N methyl butylamine. Okay, and then the final one down here. So here's that positive charge, and I've got 4 groups attached to this, which is going to make it the quaternary alkyl ammonium ion. Okay, so my longest chain is 1, 2, 3, 4. So that's going to be butyl. Oh, hang on. I'll come back to the end bit in a minute. Let's get rid of that. We'll do the ending in a moment. Okay. So I've got 3 methyls. So it's going to be N, 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 1 for each of the methyls. Trimethyl. And then I've got 4 butyl ammonium ion. Now, if there was the chlorine here, obviously the charges would cancel out, and then it would be NNN trimethyl butyl ammonium chloride. Bit of a mouthful, but anyway, there we go. Okay, so the next section here then, hexalamine. That's going to be 6 carbons. So CH3, CH2, 5, and then NH2. That's the structural formula. The skeletal formula, so 6 carbons, 1, 2, 3, 4, 5, 6, and then I'm going to an NH2 there. Just so that you're happy with that. 1, 2, 3, 4, 5, 6. Okay. The next one, N-ethyl pentylamine. So I'll start with the pentylamine. So CH3, CH2, 4 of those. So that makes 5. And then I'm going to have an NH. And then I'm going to have an ethyl, CH2, CH3. With the skeletal formula of this, so I'll start with the pentyl first. So 1, 2, 3, 4, 5. That's the 5 carbons. Then that goes to the N. Okay, don't put the hydrogen on in skeletal. And then I've got an ethyl coming off there, which is 2 carbons. So 1, 2. And that's what that one would look like. Okay, so this name is wrong here, or that beginning part there. It should be N ethyl N methyl. Okay, so let's have a go at that one. So we'll start with the pentylamine first. So CH3, CH2, 4, that's my 5 carbons there. I've then got an N, and I've got a methyl and an ethyl coming off it. So I'm going to put the methyl in brackets, and then CH2, CH3 at the end of that. Okay. The skeletal formula, start with the 5. So 1, 2, 3, 4, 5. That's joined to the N, so move that up to the N. And on the N, I have a methyl and an ethyl. And then this one, N-methyl phenylamine. Now, remember, the phenyl is benzene. So there's a couple of ways you can do this. The examples are quite relaxed when it comes to writing benzene as a structural formula. It will allow you to draw the benzene out. And if you remember, benzene looks like that. Okay. The amine is going to have an H and then a CH3 on here. Okay. In terms of the skeletal formula, there's benzene to an N and then to a methyl coming off there. Okay. So if you did want to draw this one here as a structural formula, benzene's got a weird structure and we haven't done benzene yet. So it's benzene is C6H6, but obviously we lose one of the hydrogens here where it's attached to the nitrogen in the amine group. So that part of it would then become C6H5 NHCH3. But as I say, the exam board are quite relaxed when it comes to the use of benzene in structural formulas. In terms of its solubility, again, just like the alcohols, so if you remember your criteria for hydrogen bonding, you need O, N or F, you need a lone pair of electrons, and you need a hydrogen on the O, N or F. So the amines, all of them form hydrogen bonds, and there's the hydrogen bond there. And just like the alcohols and the carboxylic acids, as the alkyl chain gets larger and larger, it interferes with the formation of the hydrogen bonds, so less hydrogen bonds are able to form, which means that the van der Waals forces of attraction then become the overriding force of attraction, which basically means it becomes insoluble. Okay, so I think that's a good point to stop, and we'll have a look at the preparation of amines in the next one.